Exploring data with a spreadsheet. We're going to dig into exploring data with a spreadsheet using the change in Omani livelihoods over time case study example. This is a case study example which is given in much more detail in topic 1 under case studies. However, a brief overview is that this case study examines survey data taken at 2 time points and illustrates the changing nature of farming ecosystems. The aim of the case study is to both document what has happened in the past and consider perspectives of the future. In analysing this data, it said in the paper on the data that the interview data was entered in an Excel database, coded and inspected for completeness and plausibility of answers. This is not uncommon to use something like an Excel database to do these things. And actually, today we're going to dig into this as an example of using pivot tables. Pivot tables. So one approach that this may have been achieved through is the use of pivot tables. These are interactive tables that can be built quickly to explore the data, running simple data checks and analyses. Now we have guides on how to use pivot tables in Excel, OpenOffice, and Google Sheets under the resources section. We also have a little guide on how to use it in R and RInstat. But of course, as always, it's up to you which software that you're happiest with. But something like for pivot tables, things like Excel, OpenOffice, Google, they are incredibly powerful tools. There are powerful tools in spreadsheet software that can be used to explore your data, like pivot tables. So let's go through the case study example. To begin our exploration, we could create a pivot table from the household sheet. Here we're just doing this through Excel, and as I said, there's a lot more information on how to actually, there's a guide on how to do this in Excel, OpenOffice, Google Sheets, R and RInstat in resources at the bottom of this topic. But here we've got a pivot table, and we can easily organize the data, placing the year as columns and both the village and household ID as rows. By having the year as columns, this layout is kind of following the structure of the study, which was in 2 years and 3 villages. Pivot tables are designed to examine important columns in more detail. So here we're going to look at the counts of household size for each year and household to provide a check on the layout variables. We use conditional formatting to add color and see patterns more clearly. As we scroll down the table, we see that the body of the table is all in the same color. This indicates that the counts are either 1 or there is a blank. This is a good sign because it means that each household code is unique. Now we can look at the average household size instead of the count. These are individual values in most of the table, with just the village and overall summary being our kind of real averages. Because we know that each household or each year for each household has just one individual, as we saw on the previous slide, has just one household in it. There's one household for each year and each ID, or there's sometimes none. So when we look at the average household size, we can see a bit more about the balance in the study. And remember, we've still got our conditional formatting on here, so we can see a lot of, with this color to help us. You know, from a brief look, it seems that a lot of acacia is a lot more green, whereas in Maziarat, and I'm very sorry if I'm mispronouncing, but in there's a few reds, and same in our 3rd village. So as we said, the gaps in the data inform us about the balance in the study. So we firstly see that in 2018, one household was not present. That was into 2018, they were not present in 2007. We also see that Keisha is the only village where all households remained. for both years, and that 10 households from 2007 were not in the 2018 data. For example, MA1, where we have a blank for 2018, but we have a value for 2007, and so forth for a few other values, a few other households. So I think what's the interesting point here is that Keisha is the only village where all households remained. In Keisha, the smallest household size was 7. In other villages, a number of the households smaller than this were not present in 2018. For example, we can see that in 2018, MA5, 6, and 7 all had a household smaller than 7, and these were not present in 2018. We do see that MA3 was still present in 2018, so we're not saying all, but we're saying it appears that smaller households seems to have left. Is this the reason why Keisha seems to have retained all of its households between 2007 and 2018? A common use of pivot tables is to provide summaries of the data. So we remove the household ID variable from the rows, and we keep the household size to give the average. So here we can see that in 2007, the average household size was 10.26. In 2018, the average household size had increased slightly to 11.07. But what about looking at just the households who are in both years? In the dataset, there's a column indicating households who remained. And so here we add the remained as a filter. So we are only looking at households who are in both years. Well, now we see an opposite story. We see that in 2007, there was a higher average household size than in 2018. In 2007, there was an average of 12.18 individuals per household, and in 2018, it was reduced to 11.00. So what does this mean? For Majorat and so what does this mean? Well, for 2 of our villages, this means that the average household size is larger in 2007 if we look only at households that were interviewed in both years. So what we mean by that is here, if we're looking we look at our first row and our third row, our 2007 household size is higher in these 2 villages than in 2018, when we're looking at only people that remained, households that remained. But when we go and look at all of the data, we see that 2007 was much smaller household sizes than 2018. There are fewer households in 2018 than 2007 for these 2 villages. The households from 2007 that were still in the study in 2018 were generally a larger size than those that left between 2007 and 2018. So the smaller household sizes tended to be the households that left the region and hence the study in that 10-year period. This is quite an interesting finding, that it's generally the households that left the region were the smaller households. Maybe there's a reason behind that. Maybe it's coincidence, or maybe it's a reason. Maybe they didn't have enough support or something else. It just gives us a start so that we can start to dig into the data. And this is what pivot tables are fantastic for. So overall, pivot tables are these interactive tables that can be built quickly to explore the data. They offer a variety of features to dig into your data in a flexible way, running simple checks and analyses. Pivot tables are available in a variety of spreadsheet software such as Excel, OpenOffice, and Google Sheets. They're also available in R and R Instat, and this is given in more information under resources for this topic. Thank you.